In this lesson, we focus on information that can be plotted on maps. We can use, as you'll see, we can use Mathematica to create a wide variety of different kinds of maps, and we can do a number of analytic techniques that allow us to extract new information from the information that we're representing in a spatial form. Now, in general, map information comes in two kinds. One kind is what is called raster information. Rasters are rows and columns of values. So a typical example would be something like a satellite photograph, where each pixel is one element of the raster. There's also what's called vector information, which is composed of things like points and lines and polygons, and these are used to represent places like cities, or features that travel along a line like a river, or areas like particular regions, states, provinces, and that kind of things. It's also possible to have what's called attribute data. Attribute data is information that's linked to a particular place. So for example, you can plot a city on the map. If your map is zoomed out, the city might be a single dot. If you're zoomed way in, the city is probably some kind of a region, which can be enclosed in a polygon, or a bunch of regions that can be enclosed in polygons. It also has an associated information, things like population, zip codes or postal codes, and that kind of thing. We're going to explore all of this in this lesson. Now, interacting with maps, and in particular getting a lot of information from the Wolfram servers, can be somewhat time-consuming, and so I have evaluated the expressions in this notebook in advance. So instead of seeing me evaluate them, you'll just see what the output is after the evaluation has been performed.